Coming up on This Week in Radio Tech, we're tackling controversy about watermarking, watermark strategy. Do you have a strategy? Are you doing it correctly? About 3/4 of stations, we believe, are not doing it right. We'll have Paul Kriegler as our guest, also Dr. Barry Blesser, coming up next on TWiRT. This Week in Radio Tech is brought to you by Broadcasters General Store with outstanding service, savings, and support. Online at bgs.cc. By the Ruby Console from Lavo. See Lavo in your future at lavo.com/TWiRT. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. And by the CalRec Type R console system. Type R is a brand new, modular, expandable IP-based radio system from CalRec Audio. Hey, welcome into This Week in Radio Tech, the show we talk about everything from the microphone to the light bulb at the top of the tower and everything in between. I'm Kirk Harnack, your host, delighted to be here. I'm today in the Telos Alliance studio in Nashville, Tennessee. So delighted, glad that the Telos Alliance affords me some equipment and some time every Thursday to do This Week in Radio Tech. And we have got a humdinger of a show for you today. We're going to talk about watermarking strategy. And yes, there's a strategy to watermarking, and we're going to try to dispel some myths. We're going to try to make some old codgers a little happier, and we're going to try to tell you that about probably 3/4 of all radio stations are doing it wrong. At least that's what our expert guest says, so we'll bring them on in a minute. Right now, I want to introduce my co-host. He's been with us on almost every show. It's Chris Tobin, and I want to introduce him a different way. Chris Tobin is such an engineer that pocket protectors wear him. Let's give it up for Chris Tobin. Hey, Chris.
That's great. I love it. Hello, Kirk.
Hi. Glad you're here. Wait, where's here for you?
I'm in the voice booth here at the radio station. I'm one of the ones not occupied. It's been a busy week. We've had a lot of musicians in, a lot of video shooting, a lot of recordings. So I just grabbed a little booth that apparently no one's using, and we're good. It's been busy.
Well, now somebody's using it, and nobody else will come in. We hope.
That's right.
And I want to introduce our guest. Our guest is my colleague at the Telos Alliance, although I don't get to see him very much. Just very rarely do we get to cross paths, at an engineering symposium here and there or an NAB show. But it's Paul Kriegler, and I got one for Paul. Paul is so tall that he puts audio processors on top of the rack. That's his security for audio.
Oh, nice! I'm just looking here at your studio. I need the Telos Alliance Studio Texas version. Is what I need to set up here. So,
well, that would be even bigger. Yeah,
I'm calling Cleveland next.
Well, I get about half of the stuff I paid for, so it's not all from Telos, but a lot of it I bought from Telos. So there you go. Hey, welcome in, Paul. Paul, let's get a quick look at your background. You've been in the radio business almost all your life in the programming area. Is that right?
Yeah, I started off in radio at a young age and programmed radio stations in Atlanta, Phoenix, before PPM came around. My last station that I programmed in a market that would have been PPM would have been probably Atlanta in 2004. But that was way before PPM, obviously.
Yeah, and so as we talk about this show is about watermarking strategy. So we're going to talk first about watermarking technology. And in my promos for the show, I promoted the fact that Dr. Barry Blesser, who's a PhD from MIT and also one of the leading developers years ago of just developing digital audio and developing some of the first products in digital audio. He's written a book. He's not here live with us, but Dr. Blesser gave a talk at an NAB show a couple of years ago, and we're going to play that talk because it really sets the foundation for watermarking technology, and it's really important. If you're a broadcast engineer in a watermarked market, which it was, most of the big markets across the country are, and some medium-sized ones are too. It is critical that you have an excellent understanding of how the watermarking technology works. Now, once we all get on the same page with Dr. Blesser on how watermarking actually works and what works for it and what works against it, then Paul is going to talk to me and Chris and you in the audience, going to talk to us about how to make it work well, what most stations are doing wrong, and we're going to look at some real-time analysis of a broadcast station and look at its watermarking effectiveness. So it's quite a show. A lot of technology is bam, bam, right in the show, and it's going to go by pretty quickly. So, Chris, Paul, does it sound like a good format for the day's show?
Fun show.
Okay.
Yeah, absolutely.
All right. So tell you what we're going to do. Let's take a quick break and hear from our first sponsor, and we're going to come right back. I'll introduce Dr. Barry Blesser. Hang on. This is the ProMix 4 from Broadcast Tools, and this thing is absolutely amazing. I got to tell Paul, your mic's hot while we're doing the commercial here. The ProMix 4 from Broadcast Tools is a mono. That's right, it's a mono audio mixer. It's a 4-channel mixer. And what's cool about the Broadcast Tools ProMix 4 are several things. Well, first of all, it's got a low price. You're going to enjoy the obviously the low price on it. It's available from Broadcaster's General Store, and it's got some pretty interesting accessories that go along with it. And like anything from Broadcast Tools, there's a lot of very efficient features all about it. So we're going to get into chatting about some of those here in just a second. Let's see here. I'm sorry. I'm having a little trouble finding some of my copy here. If we could scroll down on the page just a bit, I'm going to tell you what's on the page. There's the back of the ProMix 4. You can see the 3 mic inputs are either mic or line. Then those great Neutrik connectors that are a combination of XLR, excuse me, or quarter inch. Then it's got a program output. It's got a USB connector because it can USB into your laptop. And it's also got a mono line level input too. So 4 inputs altogether. Plus it has a balanced mono program output with a defeatable soft clipper. So if you've got an announcer that is particularly, wild, the one that yells, he shoots, he scores. Well, that guy, yeah, you can put the soft clipper in there and you won't clip the program output. You have a built-in USB interface for computer audio playback and recording. So yeah, your computer can just pick program right off of this thing and record it on the laptop. It has a mix minus output as well. So if you need to hook it up to, if you want to use your laptop, for example, with Skype or some other type of program like CleanFeed, you can do that. If you have a telephone hybrid, you plug into this thing. Well, you've got mix minus built in for the telephone hybrid. And if you're going to put phone callers on, you need that. So this is perfect for not only remote applications like going to the baseball game, football game. It's also good for parade remotes or even commercial remotes like from the car dealer or a gas station or the bowling alley or the arcade or whatever the remote may be at the county fair. It's also good to use though in your own studio. Let's say that you have a podcast studio. Man, I'll tell you what, this is the ideal console to have because it's small, effective, inexpensive, built-in audio clipper and a soft clipper, I should say, and it connects right to your PC. Plus, that mix minus makes it so you can bring callers in. It does have IFB audio input with level adjustment. It's got a line level mono monitor speaker output with a switch configurable microphone muting. So you turn your mic on, that speaker can cut off. So just like a real, real broadcast console, you've got that built in there. It does have an on-air tally warning light relay output, and it has remote channel control and status via terminal block connectors. So that's pretty cool too. It can drive multiple AHR1 Plus headphone systems. That's available from Broadcast Tools as well. And it can be combined with additional ProMix 4 and or ProMix 1 units with the ProMix Hub 6 and standard Cat 5 cable. So that means it's expandable. You are really getting your money's worth here with this box, the Broadcast Tools ProMix 4. It's available from Broadcaster's General Store. Oh, and by the way, each person on a mic with their headphones, they get their own headphone feed. Then they can adjust their headphone feed. Call Broadcaster's General Store at 352-622-7700, or you can get them on the web at bgs.cc. Broadcaster's General Store, bgs.cc. If you give them a call, talk to Hugh or Carly or Jessica, anybody there or Dave, or Chris, anybody there at Broadcast General Store, they will help you right out and talk to them about the Broadcast Tools ProMix 4. You're going to like the price, what it does, and it's a really interesting middle ground between a really cheap console that doesn't have the features that you really need versus an expensive console. So it's under $1,000. So check it out, Broadcast Tools ProMix 4. Thanks a lot, Broadcast Tools and Broadcaster's General Store. for sponsoring This Week in Radio Tech. All right, Paul and Chris, we're going to hear from Dr. Barry Blesser. It doesn't need much introduction, but this speech is really a seminal moment in the understanding of watermarking technology. So let's all grab a piece of paper and a pencil and put our thinking caps on and take a look at this. Here's Dr. Blesser.
Thank you, everyone. I'm delighted to be here. I'm especially delighted because this is one of the most unusual episodes in my half-century career, and it's for the first time I get to share it in the public space. So a quick short history. It began 6 years ago when an industry colleague approached 25/7 and said, something appears to be wrong with one of our announcers in terms of the ratings. Can you come look at it? At the time, I never heard of watermarking. I knew nothing about PPM. And I said, it's a waste of time. But they dragged me along. I listened to my colleague, and my curiosity was highly stimulated. And I said, I want to figure out what's going on. And so 25/7, with my guidance, did a pro bono research investigation trying to make sense out of it because I love a challenge. We eventually published our research on our website, and it's a white paper, and then all manner of discussions started. The phone didn't stop. We became a public clearinghouse. Radio engineers shared their experiences with me, including anecdotal insights, audio samples. Callers told me that Arbitron had the reputation of not listening to feedback, shutting down dialogue, and they wanted somebody to listen. Shortly thereafter, I was invited to be a consultant to the House Oversight Committee hearings to determine if Arbitron's PPM technology discriminated against minority stations. They didn't. They discriminated against the formats. Now, 6 years later, I can share what I learned. After being purchased by Telos 2 years ago, 25/7 turned their knowledge into what we now call the Voltair product. My goal has always been to provide our industry with knowledge and tools so they can proactively manage their relationship to audio ratings. They are a major stakeholder. Knowledge is power. Knowledge requires tools. Knowledge requires science. And knowledge requires transparency. Today, I'm going to be presenting my analysis of watermarking as a scientist without regard to the implications of what I'm going to say. Science is reality. It may or may not be appropriate. The technology I'm going to describe and the analysis may or may not be appropriate for a particular application. It may or may not satisfy people's expectations. I have nothing to say about expectations and applications. However, by necessity, if I'm actually going to look in depth into how this system works and how to analyze it, I'm going to assume the audience has a reasonably significant technical background. Some of you may get some of it. I will try to do the translation. And I'd like to ask for those people that actually understand it, when you go home to your organizations, you translate it for the benefit of those who do not have the technical background required to appreciate the implications. As a side note, PPM, which is a registered trademark of the Nielsen Company, belongs to a larger class of audio watermarking system based on multi-channel, multi-level frequency shifting keyed encoding with perceptual masking. My analysis applies to any system within that class. I am not picking on any one particular embodiment of this technology. For months, Telos and Nielsen have engaged in meetings and discussions to find a win-win path for all the relevant stakeholders. Along the way, Eric Rubenstein, Nielsen's chief legal counsel, asked me to read the following statement. Telos is working with Nielsen to support their efforts to test the effects of Voltair on audience measurement, with the results to be validated by the MRC. And now we can do some technology, which I always enjoy more than the politics. Okay, the first step in this is watermarking is a system. It has to be analyzed as a system. This is a cartoon-like description of the system. It starts with the program management selecting content. It goes out into your transmitter chain, including watermarking. It then goes through the transmitter. It comes to the receiver. It goes to some acoustic environment, and some decoder and ears pick it up. It then may go to a computer, which may do other kinds of data manipulation, which I call assembly rules and edit rules. It's a system. We need to understand this as a system. And it's not trivial, even though it looks like it is, because it's a time-varying, nonlinear, two-channel system, and there are multiple versions of this around in the entire ecosystem. So let's now take a look at, by the way, I'm compressing 5 years of research into 30 minutes, and even though 25/7 is a time compression company, I'm not going to be successful. I could try talking faster. Okay, the first thing to understand is we in the industry are managing a dual channel system. We forget there's a second channel because we never had any visibility into the second channel and we never had any ability to influence it, so we just quietly forgot about it. But let's now look at this second channel. The top line here is your main channel that you're all familiar with. Somebody creates some speech or music, you have human listeners, and there's noise corruption, which may correspond to watermarking tones and the environmental noise. And the purpose of this channel is to attract listeners. Okay, you know that. The second channel is a watermark encoder, which creates its own signature payload. Its target is not the listener, its target is a portable decoder. The type of signal is frequency shift tones in multiple channels. There could be other technologies, I'm just talking about this one. And in this case, the key, the noise corruption, is the music and speech and the environmental noise. It doesn't care, and the purpose of this is to register listeners. And you got to think about it as a two-channel system, because your programming is to attract listeners, and the second channel is to catalog their existence so you can get advertising revenue. Doing one without the other gets you nothing. If you have a perfect watermarking system and no listeners, you're off the air. If you have a zillion listeners but the advertisers think you have none, you're off the air. So to think about the two channels, and that's really the purpose of my talk. Okay, so let's start looking at the second channel. And I'm going to be using what I call the common language of the second channel, and it's a time frequency spectra. Most of you are comfortable with time domain representations, a la your oscilloscope, and you're comfortable with frequency analysis. There's a combination hybrid, which is the central key. You have to look at time and frequency amplitude simultaneously. This is a typical message that might come out of a watermarking frequency shift keyed system. You can see here these big lobes. If I could turn this around, you'd see they're sequential. At any given time slot, there's one frequency, and then at the next time slot, there'd be another frequency. And you can look at this. Any sophomore in college could do a signal processing technique to extract this. You could get the watermarking payload perfectly if this was the picture. Unfortunately, this is not the picture. Okay, now, that picture I just showed you before wants to be injected into the audio stream. Well, guess what? If you just injected it at full level, nobody would listen to your program. And I had a demo of what it sounds like. It's really uninteresting. It's just tones, steady state tones for half a second, then the tone changes a little bit in frequency. So we use the principle of masking. And masking says if you have a large audio signal, in this case this square block with some kind of envelope, the ear becomes temporarily deaf before it, believe it or not, even though the signal came before, and after it, and at frequencies above and below this. So in other words, you cannot hear anything under this quilt that I've laid on top. You are deaf. So this is a perfect candidate for two activities. And I'm going to mix together the fact that there are two activities involved in this. Obviously, the watermarking system can stick tones and other signaling under this because you can't hear it. And so it's great. You just can't hear it if you get under it. And just as a complete jump to the next lecture some years later, it turns out this is related to the codec industry because they do the opposite. They sit there and say, anything under this blanket, I don't have to encode. I'm just going to throw it away. So oddly enough, watermarking and codecs are first cousins of each other, and very often they will fight each other for this turf under the blanket. One says, I'm going to throw it away, and the other says, I'm going to put it in. And so it opens up a new class of things to think about. Who owns the under the blanket area? Okay. Now, let's look at what happens in this time frequency spectra. And this is a typical piece of audio that might be broadcast. It doesn't look familiar because most people don't look at it this way. Now, if you go back to the previous slide with the blanket, the watermark encoder takes that blanket and has to lay it over this complex time frequency map of the audio program. And it has to figure out where in this soup can I stick the tones. Now, oddly enough, perceptual masking, which is what I'm describing, has been around for a very long time. I was taught that in the 60s as a student. Unfortunately, the academics were not interested in what we're interested in. So they were doing a scientific modeling of the auditory system for masking, and they were using clicks, sine waves, tone bursts, all these scientific signals that were easy to reproduce and easy to describe. To my knowledge, there is no literature that tells you how masking works with real audio, as in speech and music. There is no literature I've been exposed to. However, there is a massive quantity of research, especially in the last 10 and 15 years, in the codec industry. And there, the research, unfortunately, is proprietary. It's not academic. They don't publish it. But they have really been pushing the envelope in understanding how to get the masking to take advantage of these complex codecs. The same thing should be done for watermarking because it's the same issue. I want to understand where to stick it. So if you were the encoder and I gave you this picture and says, okay, where are you going to stick the tones? You might scratch your head. This is a non-trivial challenge for the designer, and you can't escape this. I have not heard anything about the upgrades to various watermarking technologies in terms of including new masking technology. I don't know how available it is in the public space, but certainly there are about a dozen different organizations that are actively engaged in studying how to do this. Okay, let's move on. Now it gets really exciting. Remember I said before that frequency shift keying is a matter of putting out a sine wave at a frequency. So in a typical frequency shift keyed system, say with 16 levels, you might have 16 possible frequencies. They might be spaced 30, 50, 100 hertz apart. And one of these signals, which I call a symbol, may go on for 400, 500, 600 milliseconds. If you look at this piece of spectral content, it has a nice peak at 1 kilohertz. As you'd expect, I give you a half second of 1 kilohertz, and I say, what's its spectrum? And you say 1 kilohertz. It's easy. And what I've shown here in these blue lines in this hypothetical watermarking system, this might be neighboring target frequencies. So the decoder has to determine, is that 995.5 hertz that has one meaning, is it 1,000 hertz, or is it 1,004.5 hertz? It's got to decide, because in some of these technologies, the choice of tone frequencies is very closely spaced. Well, we know that any sophomore could figure out what tone was being transmitted. However, remember I said we got a masking system which is not leaving that tone on, it's turning its amplitude up and down. What happens if I take that 400 millisecond signal, and let's say there's no masking for 300 milliseconds, and it comes out as a 100 millisecond burst? What does the spectrum look like? Well, two things happen. The amplitude drops dramatically. In this case, it drops by about 14 dB. And the signal-to-noise margin in the neighboring channel goes from a really nice 15 dB to 2-point-something dB. In other words, the margin of tolerance to extraneous junk, whether it's junk that came along with your program or junk that got introduced in the listener's environment, the tolerance goes down. And guess what? If I get the channel producing a 25 millisecond sine wave representing the 1 kilohertz, there is no technical way anything can decode that. You have a fraction of dB margin, and unless you had a pristine system with no anything, that is lost forever. It is undecodable. Okay, just to give you a perspective, here are those three cases I just described. This is the 400, this is the 100, this is the 25. You can see very clearly this is real signals with a real spectrum analysis, and basically this gets flattened out, there's nothing left. So the duration of the signals becomes the key piece for decodability. So what happens in the real world? This top thing, I'm sorry the picture's not so good, That's a singer with a piano. It happens to be my son, so I don't have any copyright issues. And that's the you got to worry about it. I know there are lawyers in the room. Okay, my son signed a waiver. Okay, now, if you now say, let's go back to that time frequency map and say how much channel 1, which is around 1,000 hertz, could be injected, it's going to analyze this for how much masking can be produced using whatever masking algorithm. The first thing you notice is the amplitude is low, but it's also been amplified by 20 dB. And you notice these watermarking tones are going up and down, sometimes very rapidly. In other words, the information is being turned on and off. But from the previous slide, if I don't leave it on long enough, I get nothing. And when you get up to channel 5, it's really low. It's there. You know, some of these encoders can code down to minus 70, minus 80 dB. You just can't get it to the other side. Okay, now there's a class of signal out there which has a time frequency spectral analysis, which shows there's nothing up here. 1 to 3 kilohertz, you got these tiny little needles, and the encoder says, oh, I can turn a tone on, oh, I got to turn it off, oh, I can turn it on, I can turn it off. And you get these little needles, and as anybody knows, if I give you a half millisecond of 1 kilohertz, it sounds like a click, because that's what it is. So this kind of program material will not encode. Now at this point you might say, well, this sounds pretty bleak. Well, there's another side to this which is very optimistic. The typical systems have massive redundancy. So the same message may be sent out thousands of times in a 15-minute interval. You don't have to get many of them to assemble it. So you get symbol 1 at this moment in this channel, symbol 2. You put it together and you assemble it. You're great. So the system can have massive errors and work perfectly. What's the assumption? The assumption is the accuracy and errors is random. And you know if it's really random, like Gaussian, everything will work fine. Unfortunately, statistics can lie if you don't have the assumptions. So the statistical assumptions about all program material is one thing. The statistical assumptions about your typical male announcer with a cold is completely different. And so some program materials each program material has its own statistics. You can't take global statistics and apply it. And if you happen to be unlucky, like the Hispanic stations in 2009, their statistics worked against them. Now, you can say there is energy, and what you can do if you do these maps, you can often see a lot of energy, but they're needles. If you get needles, you're out of luck, or rather the decoder is out of luck. And if you zoom in on one of these things, you get even a more graphic picture. So this is a zoomed in version of a real signal off the air. Now, if you happen to be an encoder at 1 kilohertz, all you care about is this stuff. And as you can see, it comes along, turns on, immediately turns off. Then it's off for a while, comes on, turns off. So you'll get stuff coming out of the encoder. You'll get stuff arriving at the decoder. But there's no theoretical way that anybody can separate 1,000 hertz from 1,005 hertz. The mathematics will not allow you to do that because the time frequency product is always approximately 1. So if you want a 5 hertz resolution, you need 200 milliseconds. You just multiply the two together. And if the product is significantly different than 1, you're SOL. Sorry for the foul language. Okay, so let's do a quick summary of what's going on. You have to follow the time frequency spectrum through the system. This is on the second channel and the main channel, because the main channel is what turns on the second channel. You have to look at the program material in terms of its masking and what kinds of tones are going to be injected. You have to examine the spectrum of the watermarking tones. Then at the decoder, you have to consider the fact that the program itself is overlaid. So the same program that turned on the watermarking tones also is sitting there to clobber them. And so it's kind of an arms race with it. And then you have to consider the listener's acoustic environment. And the question is, can the decoder find enough tones, doesn't have to get a lot, to assemble it into a plausible message or even an approximate message such that the edit rules can go figure it out what's going on. Okay, we came up with a product called the Voltair, and its purpose in life is to do two things. It's to give you some visibility. This is an emulation. I had no intellectual property. I just sat there and looked at the signal coming out of the encoder and said, okay, what would I do? And then I came up with the fact that there are theoretic limits. So the Voltair actually is based on the assumption of doing at the best that is theoretically possible. It doesn't tell you that that's what a particular system is actually doing. And what you have up here is before processing, after processing, and by changing the time-frequency spectrum relationship between the signal and the watermarking in the critical frequency region, you can get dramatically better results. I was going to talk about this, but you can grab somebody in our booth later if you want to know more about it. Okay, when the system is working well, as in you choose the audio perfectly, you do the Voltair enhancement, you have a quiet environment, everything perfectly, this is what you get for the watermarking signal. And you notice in this case, every channel's got energy. It's a bit chopped up, but it's mostly on. So this channel has got a little bit of an envelope. This will decode perfectly. You'll get hundreds of accurate messages, no problem whatsoever. So the system can work great if the assumptions are there. Okay, now I'm going to jump to what do we want to do with all this. So this is all academic. Now you say, okay, how do I make sense out of this in the real world? We're not interested in a particular listener, even though I've only simulated one listener in the Voltair. You're interested in your hundreds of possible listeners out there, and you're trying to figure out what enhancement to use, or you got a more or less knob on your processor, and you want to decide, how much should I do? Well, if you were to take all the listeners that you're getting credit for, or let's say you take an individual listener, and what I'm going to call it parameter X, it can be anything in your chain, and you plot it, as parameter X goes up, you get a 100% probability of getting this listener. As parameter X goes down, you get a 0 chance. And depending on the program material, depending on the acoustic environment, depending on everything in the phase of the moon, you'll get some S-like curve which says at one extreme you get nobody, at the other extreme you get 100%. Nobody's surprised. Okay, what you get from the mothership is all your listeners collapse together, and you could do a mental experiment and say, okay, I've got a possible of 100% decoders out there. What percentage will I capture for a given level of parameter X? And you don't know because none of us have access to it. So you could, if you could make a measurement here and notice you got so many listeners, however it was, and a measurement here, you get a different number of listeners. Well, in the Voltair, we built in a GPIO, which allows you to toggle from one value of enhancement to another. You could also do a GPIO on your processor, anything you wanted. Now, you could toggle this every odd and even minute. So you take all your odd minutes at, let's say, a value of 12, and even minutes a value of 13, and then weeks later, maybe you get the results. You now do an analysis, and the beauty of this, because you're toggling every minute, you don't have to deal with changes in school vacation. You don't have to deal with weather. You don't have to deal with all the anomalies out there, because the world stays relatively constant over 1 minute. It doesn't stay constant if you do an experiment 1 week, and then 6 weeks later you try a different experiment. So if you do the statistical analysis, you can now draw a straight line approximation. You know where you are on the curve. You know if you're up here, such that if you crank up more of parameter X, you're not going to get anything. Or you know if you're down here, you're in deep doo-doo. Or if you're up here, you can then decide. But I wanted to go further. So I said, all right, you know what? Let's do a 3-point GPIO system where you can make a measurement here on minutes divided by 3, modulo 3, and you get 3 data points. Guess what? With 3 data points, we can approximate a parabola. It's extrapolating. It's not truth, but you can actually approximate what you would get for the percentage of listeners had you set parameter X over here. Now, maybe you don't want to set parameter X up there, but you now have a measurement tool using Voltair, which will give you an approximation for what percentage of listeners could you have gotten had you manipulated parameter X. And it doesn't have to be just X. It can be parameter X, it can be parameter Y and Z. You can do all the experiments. You can do an experiment like this with your STL codecs. You can do this with your processing. Voltair is allowing you to measure the entire system chain for this second channel. Remember, you're in a 2-channel business. You're not just in the program business. Okay, so let's do a quick summary of what we are. Okay, so the radio watermarking is a complex ecosystem. It's not a box. A box is not a system. And all the stakeholders are involved in the total system. Nobody owns the system because it includes all kinds of things. Nobody owns, the program director. Nobody owns the music sources. Nobody owns the listener's environment. Everybody can be a stakeholder to improve it. Audio processing tunes the program. Voltair can tune the Watermark channel. It's a direct analog. You've got boxes that tune channel A, and now you have a box that tunes channel B. Programmers can tune the system by evaluating the content. It's now a level playing field for everybody to be a participant in the management of the system that's so important to them. And I did manage to squeeze it in. And I know there are going to be lots more discussions, so I'm going to be available because we're going to have another talk in a few minutes. And I got the timing perfect for questions, which I wasn't sure I was going to. Thank you very much.
And now we have some more time and experience under our belts from the time that Dr. Blesser made that talk, and we've learned a lot. So, hey, I'm Kirk Harnack. You're watching This Week in Radio Tech, episode 449, where we're talking about watermarking strategy. And that means a lot of things, but it mostly means best practices in doing it right. And I said a couple times during the show intro that a lot of stations aren't doing this right. And we're talking with Paul Kriegler of the Telos Alliance, who's got a lot of experience both in programming, so making sure his stations sounded great on the air, didn't have any problems with the audio on the air, and yet we got to do watermarking. And Chris Tobin is with us here too. Chris is sitting in market number 1, where watermarking is pretty darn important. So we're going to break for a commercial pretty soon here. But Paul, what can you preview for us? What we're going to be talking about in the second half of our show?
The one thing that broadcasters can take advantage of right now is to use insert points in their audio processing chain to deliver audio. Basically filling up the bucket of your encoder before it goes on downstream.
Good. And we'll explain what part of Dr. Blesser's talk, points to that being a necessity, and also, why that helps watermarking, and also why it allows stations to not push their watermarking so that it's audible. Obviously, we don't want watermarking to be audible, and we know that on plenty of stations, it can be. So we're going to talk about that. And Chris Tobin, I'm sure you're going to chime in because you are in the presence of lots of watermarked stations in market number 1, aren't you?
Oh, yeah. Yeah. Well, one of the things I have to say in the early days of the watermarking projects, one of the things we discovered was the source material needs to be very clean, very dynamic, and you need to have that. So while you're filling the bit bucket, if you will, you got to make sure the stuff going in is as dynamic as possible to let everything work together. As Dr. Blesser said, it's a system, not just one item at a time.
Yeah, the whole watermarking. I mean, the purpose, of course, is counting listeners, and it is from end to end. It's from the origin of the music and how we can manipulate the music to transmitting it with the encoding in it, and then the listener's environment, which we don't have any control over, and their pocket-sized detectors that listen to what they're listening to and try to pick out these symbols from the audio without their ears picking out, the noise that making the symbols makes. So that is coming up. Paul's going to have some good advice for us, and we've got an interesting video to show you. We're going to talk about a station we recorded yesterday in real time. We recorded a station that is doing watermarking, and we'll talk about what may be right and what may be wrong with their signal and how you can avoid that station's mistakes. All that's coming up. We're going to be right back after this word from CalRec.
TWiRT is CalRec's first native IP-based mixing console. It is fully AES-67 and NMOS ISO4 and ISO5 compatible as defined by SMPTE 2110. Connectivity via Cat5e utilizing COT switches and power to the surface is supplied via standard PoE switches to minimize cabling. Its 2U core has integrated I/O, so you're instantly up and running, and it can power up to 3 independent mixing environments, each with their own separate DSP resources. TWiRT's surface is modular and expandable, consisting of 3 slimline panels, each of which are user-definable with layouts saved and recalled quickly between shows. It's available in 4 DSP packs, and as your station grows, larger packs can be added, making Type R the most flexible radio console you can buy. Find out more at calrac.com/TWiRT.
Indeed. Check out Type R at calrac.com/TWiRT. Really appreciate the /TWiRT on there, too. Hey, studio guests are only human, and they cough and they sniff and they clear their throats, like on the air. You can cure this with the Angry Audio Guest Gizmo. You press the cough button, and it mutes the mic. Every guest needs one. You know what else they need? Headphones, which is why each guest gizmo also has a studio-quality headphone amp with individual volume control built right in. Anything else? Well, you see those mic arms that have those built-in LED tallies. And they're beautiful, but how do you light them up? Yes, Gizmo does that too, providing just the right voltage, illuminating the red light whenever the mic is hot. And installation is easy. Couldn't be easier. All you need is a 2 3/4 inch hole saw and a steady hand. No router required. Your studio gets a clean custom appearance, and you get all the credit. Check out the Guest Gizmo and the other cool gadgets at angryaudio.com. That's angryaudio.com. And I'm serious, you got to go there. You got to check out the cool stuff that they have. In fact, I would appreciate if you go to any of our sponsors or advertisers and check out what they've got, because they support this show and the teaching that we do and the learning that we all get to have from our guests and speakers. So we learned a lot from Dr. Blesser, and even though that speech was a couple of years old, everything in there still holds true about how watermarking has to work. And the key thing that I pulled away from that, because I used to think about this technology myself, and a misconception that I had was about the length of time that an underlying, hidden, if you will, masked tone, the length of time that tone had to be present in order for the fact that it was there at the frequency it was put in there to be received at the other end. And I didn't realize how relatively long that is. For 1,000 hertz tone or so, you've got to have several hundred milliseconds of time that tone has to be there. Otherwise, it can't get decoded at the other end. You might encode it. If you encode it and it's not masked the whole time, you're going to hear it. So the encoder of these watermarking encoders, they analyze their opportunities to insert these FSK tones. And I use that word actually pretty rightly. These encoders are opportunistic. They're looking for places to put their tones that describe or uniquely identify the audio channel to which you're listening. That would be the radio station to which you're listening. And if the opportunity is not there to safely put a tone in, then it's not going to put a tone in. And it's the combination of these tones that identifies, kind of like a barcode, right? It identifies the audio channel, whether it's over the web or over the air, that you're listening to, or that your decoder is in the presence of, I should say. If the tone can be masked long enough, then the encoder will put the tone in at these different places. Now, there's a lot of redundancy built in. There's a lot of really smart redundancy built into this, and you don't need lots and lots of opportunities for the tones to be placed without hearing them for this to work. But you do need some. You do need some, and that's where the strategy for watermarking comes in. Paul, you know better than I do, but I know that the predominant company that does this watermarking, and I will say they're not the only one in the world. I think we're at liberty to mention the French system, which is called Kantar. And the Kantar system, Paul, I believe I've heard you say that the Kantar system, audio processor manufacturers are allowed to build that code into their processors and have it reside in the audio processors such that it can be opportunized to work best. So tell us for just a minute about Kantar, what Omnia has done with the Kantar people and how that's working out in France. And then we'll go to the system that we have in much of the rest of the world, including the U.S.
Oh, if you're in France and you have watermarking needs, you can do it right inside the audio processor. Now, what's important is if you go back to that Barry Blesser piece, there was one slide that he showed where he showed you the entirety of your station's air chain. And, if you can zero in on that one part where it shows the audio processor and it shows arrows going to and from the encoder, that's a really important part of that process. So part of what Chris said earlier, and what this really comes down to is a lot of good engineering practice, good level management in your broadcast plant, reducing distortion in your broadcast plant. Unfortunately, one of the problems that we're faced with as programmers, and you hear it all the time, is you hear source material on some very large hit records that put a lot of things like distortion right in them to begin with. So depending on the source audio, not all source audio, not every song is created equal. And I think most of us, who have dealt with watermarking over the years have kind of picked up on that. But with the TVC15 that we offer, this actually gives you a chance to look at your watermark closely, where you can scrutinize, short snippets of your radio station, look at where you may have certain program segments, features that you might do, and see how those perform as the two channels are trying to coexist there within your program chain.
We saw Dr. Blesser talking a lot about using an example 1 kilohertz for putting a tone that gets masked by the audio. We understand that the watermarking system used in the U.S. wants to have tones from 1 kilohertz up to 2 kilohertz and maybe even up towards 3 kilohertz. But that's the audio range where this system can work reasonably well with pocket-sized decoders. And so that's why there has to be audio information in that range. And let's just, for sake of discussion, say it's 1 kilohertz to 3 kilohertz. There's got to be enough audio. In other words, if you were to transmit, if you were to play songs, but completely notch out from 1 to 3 kilohertz, first of all, you'd have some weird sounding songs. But second of all, if you did that, you would have no watermarking on your broadcast station whatsoever if you notched out all the audio from 1 to 3 kilohertz. So you got to have audio that is dense enough and long enough in that 1 to 3 kilohertz range for a watermarking system like this to work. Do I have that about right, Paul?
Correct. And
Okay.
that's why using insert points really does the trick here, because all of our audio processors, most audio processors, not even ours necessarily, our competitors, the AGC, the wideband AGC and the AGC sections, the stereo enhancement, those are all good things to have in front of your encoder. At that point, and that's kind of what I meant earlier by filling up the bucket. You're doing a good job at level management so that an encoder sees good, consistent levels within a reasonable range.
Well, let's talk about why that is. And Chris, please feel welcome to jump in. If the advice has been to put this encoder before your audio processor, the encoder is receiving audio that is fairly it's unprocessed, except for whatever was on the record. If on the song, if you're playing songs, if you're playing dry voice, well, it may be almost not processed whatsoever. So there may not be as much opportunity in that. There's no lift. There's no underlying level lift if the audio is unprocessed coming in the encoder. And so, Paul, several times now you've said put it at the insert point. Tell us what, so the insert point is after some of the processing in a processor. We know there's several stages to a typical modern day AM or FM processor or a TV processor. There's several stages of processing. Where is this insert point in that mix?
Depending on the audio processor, you can pick a point within your digital audio processor and send whatever point you'd like, depending on the manufacturer. I do believe in the Omni 11, it's right after the stereo enhancement section before the limiter. So you come back in for final limiting and stereo pilot. As you can see, I'm not the scientist, and I'm certainly not Frank.
Nobody's Frank. Hey, Chris, I don't engineer for any stations that are in measured markets or PPM watermarked markets. Chris, have you had an opportunity to set up encoders in a watermarked market? And if so, what's been your best practice at this point?
Well, I have set up in watermarked markets, measured markets, and I did it for spoken word stations and for music stations. And if you carefully read what paperwork is available and listen to Dr. Blesser's presentation, he's talking about that masking net, that little fishnet image he shows you. That's where the encoding needs to take place. So think of that process. If you've ever listened to a, say, classical music station in your car, that's not very processed. You notice there's a lot of passages that sound like it's silent, but it's really not. It's only minus 50 dB down. What you need to do for the watermarking to work so that it sees an opportunity to encode is to keep that noise floor, not noise floor, but we'll call it the audio floor, up at a reasonable place so that it still sees it and says, oh, there's something coming, I have an opportunity. That would explain why in the early days of watermarking, spoken word stations had such a wild, various number shift and, reports of what's working, what's not working. Think about it. Conversation, how often do you have enough of 200 milliseconds of audio to be able to encode and get something out while in a conversation? Well, unless you're a hot format jock that's talking and you keep talking and talking and you're listening to yourself, maybe you will, but normal conversations in sports, news, or talk show doesn't happen. That's why you had the early days of what the heck's going on. So then, processing approach was taken of, okay, how do we raise the level? How do we manage this? And because of proprietary design, none of us in the industry really understood what we needed, because back in the day it was, well, you got to make sure you're putting +8 into the box. Well, we haven't used +8 as a house reference for 30 years. Now what do we do? And I worked at a facility in New York City where we had to come up with a way of getting +8 into the box from our +4 plant and then back to +4 to go into the rest of the transmission system. So, as again, referring back to that presentation of it's an ecosystem of how this works, it was a nightmare. Now I know it's improved considerably since, but you have to really tear apart the way this methodology works to understand why the insert points that Paul's mentioning are important. And it's not just arbitrarily chosen. It's because of the physics involved. It's opportunistic audio encoding. Well, if I don't have an opportunity, I don't do it. How do I get the opportunity?
Right.
Keep the level up. So it's sort of like walking across a subway grate here in New York City and your skirt goes up. Well, it goes up for a certain amount of time as the train passes by. Guess what?
Yeah.
That's the time to encode. We got an encoding opportunity. Let's go. That's pretty much how it comes down.
This is why my voice doesn't encode well, because I don't wear a skirt. This is the problem right here. But actually, Chris, I'm glad you've made that analogy, because it actually, when Dr. Blesser was talking about that blanket effect over a tone, and it changes wherever the blanket, whatever's below the blanket or the quilt, if you will. That's where you can insert audio and the brain can't hear it. And I know that's true. This was an experiment I did at Telos years ago, and it absolutely worked when we were understanding how MP3 works. MP3, of course, audio psychoacoustic coding doesn't encode anything underneath that blanket, whereas watermarking inserts tones under that blanket. Either way, you can't hear it. I would think that if you can provide to the encoder the same audio, but everything's lifted a bit. In other words, the blanket, as you said, it's been blown up a little bit. So if there's some noise that's way down, we lift that noise up a bit. If there's some reverb that's down, we lift that up a little bit. Let's say there's some instruments going on in the acoustic or the song mix that are kind of down. We bring, what processing does kind of helps to bring those up. Then it provides more opportunities for the encoder to say, aha, I've got 300 milliseconds right there. I can insert this tone right there, and nobody's going to hear it, because without that opportunity, it is going to happen. I think I'm analogizing that about right. We want to give opportunity.
Very well. Well done.
Yeah. For some things, there's no hope. And for years, I heard that, through the grapevine, that Well, a particular opinion celebrity voice doesn't encode well, and that's Sean Hannity. And I'm sure people on one side of the fence are delighted about that. People on the other side of the fence are not delighted about that. And other people probably don't care. But so Sean's voice doesn't encode well. I would imagine that most of his fundamentals in his voice are under a kilohertz, but his overtones are kind of raspy. And so they're not very long lived. They don't provide opportunity for the encoder to do anything. So if not that you would, but if you were to actually insert pink noise under his voice, or maybe teletype noise, or some low level music or something behind
Metallica.
A dry voice. Metallica, there you go. That encodes very well. Then you're going to get better encoding. So, Paul, why don't you? What's been your experience about music versus certain kinds of commercials? Some commercials encode really well, some don't. What's your insight in that?
So Barry gets into that towards the end of his presentation, where he talks about using the GPIO and the Voltair to toggle different preset points. TVC allows you to millisecond by millisecond adjust the program material due to what the TVC is saying, what it's seeing through the sample port, and then controls your Voltair accordingly. So you're going to hear less artifacts. You're going to hear less of that.
Let's roll that video. We're going to run out of time here before too long. So let's roll that video and talk about over it what we're seeing here. So what we're seeing here is a product made by Telos, made by the 25/7 division, called the TVC-15. And this product is listening to a radio station. And it's listened to it off the air. And it's able to, every green check mark along the bottom is a good word. In other words, it says, hey, I absolutely decoded what station this is. There's a check mark. Where there's no white box with a check mark, that means it didn't get it. Now, we did this yesterday, and I sped this up 4 times so we could talk about it more. Paul, tell us about the confidence line. What are we seeing there with the red and green and yellow?
So on the top is sort of the deconstructed front panel of a Voltair, but this is taking the analog sample input of the TVC. The neat thing about the TVC-15, it is literally the simplest box we've ever made. It's got an analog input, 2 channels, it's got a front screen on it. If there is watermarked audio present, this is exactly what you're going to see. You can use an off-air input from any radio. You could use, you can stick it in your program chain and have it control your Voltair real time. So this unit really has 2 different purposes. It can be just an analyzer, which is what you see here, or it can control your Voltair real time and turn it into a dynamic unit. Let's see if I can look here at the screen. What you're seeing, that you're looking at what appears to be a commercial break. This is right at about the point where we were going, how much longer can this commercial break possibly go on?
This is a long commercial break, yes. And we're looking at look at that red, all that red coming by right now. That might have been a dry voice spot. That was a dry voice 15-second break is what you see there. And not all dry voice is created equal. Some dry voice actually encodes, but you could see the 30-second spot right after that where there's background music behind it. If I was a PD, I would go back to my commercials or anything that I have on my station and try to make it a wall of something underneath everything. That's the best way I could put it. I would put something underneath everything if I could. Now, the white, on the enhancement bar, that white graph that keeps going up and down, tell us what that is all about.
So that's the enhancement level. If I was, if this was on the same network as your Voltair and the 2 were talking to each other, if you see the AE, which is, why am I doing dynamic enhancement.
The automatic enhancement.
Automatic enhancement. Thank you. I'm like AE. I'm thinking Aeneid. Okay, so you see that number going all over the place. That corresponds with the metering that you're seeing down below. So where you see all the red up top, it would take your unit up to the highest setting it could possibly go to. In this case, I have the TVC-15. If this was talking to a Voltair, it would be set maximum at 18 and minimum at 6.
Okay, now I want to point out that this TVC-15 we're looking at, this is not connected to a Voltair. So the enhancement bar is the enhancement that this box would be telling a Voltair to do if it were hooked to one. But
based on
it's not
this exact program material. Yeah, based on this exact program material.
Yeah. So, but you can see that where it's green, where there's a lot of green bars and the confidence is good, then this TVC15 would be telling the Voltair, hey, don't do much of anything. You're fine. You're really fine.
Kirk, before this goes away, I want you to see right here where you see confidence up top and you see that swath of red. That was the beginning of 7 rings from Ariana Grande.
Oh,
and that is what a very quiet 5-second intro looks like. Maybe longer.
Okay.
Right. But yeah, I think that was longer than, but that's what happens. That's why.
There's a piece of mitigating advice here.
So I just want to say some programmers have caught on to this and edited songs, like edited intros of songs and things like that to keep the tempo going on the station.
So you have some mitigating advice. Let's say a station is analyzing their watermarking effectiveness with this product, the TVC15, and they're seeing some red now and then, or even pretty often. You've likened this to a grain of sand on the beach. What do you mean by if you see some red, is it the end of the world, or what's the deal?
Well, as Barry said, I mean, I think within there are safeguards within the system. This is about doing all you can to keep that watermark there. It is the most valuable thing that you broadcast besides your content, and this gives everybody a chance to really go in and study exactly what's going on. And I if it were me, I would look at I would spend some time with this unit. I would look at my competitors. I would look at my own station, and I would study my weaknesses.
I want to ask Chris in just a minute if he's ever seen this kind of analysis. I must say that if you've got some time there that your confidence is in the red and you're not getting any of those check marks at the bottom, it's not the end of the world. It just means that if somebody tuned in and tuned out during that period, your station might not get credit for that. But if they tuned in during one of those bad parts and then they kept tuned in long enough to get some check marks, then you would get credit for that. So you're not going to miss a pebble or a grain of sand from the beach. Just make sure you don't go down the beach with a bulldozer and get rid of all the sand, right?
I would be trying to avoid 2 minutes worth of red. I would be trying to avoid 15 minutes of red. That's when it gets to that point.
Yeah. Chris, so what have you looked at any stations with this kind of box?
I don't. No, I have not. I don't have that box. Okay. I've watched it on the show floor many times and had enjoyed what it can do. I'm just curious that on the red indication that we were watching, when it was low and did not get a checkbox for for encoding, is that because of just level, or is it because it was silent, or both?
So that is the intro of 7 rings from Ariana Grande. So the intro of that song is very, very quiet. And this particular station plays the quiet portion. If there's no audio there, there's nothing for the watermark to latch onto.
Okay, that's what I thought it was. There's no audio.
That confidence
threshold. Okay, gotcha.
Yeah, we should point out the confidence there is reflecting that unit's ability to decode the watermark. It's not now. Level is kind of a proxy because obviously, if there's no audio level, there's no opportunity for the encoding to go in there. So it's a little bit of a proxy for density and for level. But you could have a really dense bunch of program material, and if you had no audio between 1 and 3 kilohertz, as we postulated earlier, you'd have zero confidence. You'd get no watermark. It would be a problem. Yeah. So that album Marcel Marceau's Greatest Hits, that doesn't encode well at all.
No, silence is not your friend.
Silence
is not air has never been your friend, really.
That's right. That's right.
Never been mine.
Now, I'll tell you what we're going to do. We've got a hard out time in about 12 minutes. What I promised at the beginning of the show and promoting the show is what are stations typically doing wrong? And Paul, you've addressed that to a bit of a degree already. And I also want to address the question of when people say, "Oh, those watermarking tones are horrible. They sound awful. What is our industry doing to itself?" And my answer is, well, if you can hear them and they're bothering you, there's a very good chance that you're doing it wrong. And let's look at how you're doing it. So I want to address those 2 points. What are stations doing wrong, and what are they doing wrong? If people say, I hear fingernails on a chalkboard, let's talk about that. Right now, we're going to take a quick break and hear from our friends at Lavo. We'll be right back.
There has probably never been a better time in history to buy a new radio mixing console. Today's consoles are more sophisticated than ever, with more features and functions than you can shake a stick at. But have you noticed how complicated they are? There's a sea of knobs and switches and displays and buttons. Some of them look like you might need a pilot's license to do your show. Well, a board doesn't have to be complicated to be powerful. Just look at the new Ruby mixing surface from Lavo. The first thing you notice is how smooth and streamlined it is. Ruby has lots of cool tech, but what it doesn't have is that confusing ocean of buttons that clutter things up. Now, we all know that there are some console features the jock only uses once in a while, so why dedicate controls to them? Ruby fixes this problem by moving those once-in-a-blue-moon controls to a touch-sensitive, customizable GUI that happily shares screen space with your other studio software, helping you fight control room clutter. Thanks to this design innovation, talent that use Ruby produce smoother shows with less errors. Controls that are used the most fall naturally to hand, while functions that rarely need adjustment are easily controlled with just a couple of clicks in the context-sensitive GUI. And Ruby has cool features you won't find on other boards, like Auto Mix, an intelligent gain writing function that guarantees the perfect mix for multi-mic morning shows and call-in segments. Dual mode snapshots that instantly switch the motorized faders between on-air and production modes, and enough DSP and I/O options to make even your pro sound pals green with envy. And because quality is as important to Lavo as it is to you, every console is proudly built to fanatically precise standards at Lavo's own factory in Germany. If you're ready to declutter your control room, do yourself a favor. Check out the new Ruby and the other cool Lavo radio tech at www.lawo.com/TWiRT.
Thanks to Lavo for sponsoring This Week in Radio Tech. Really appreciate it. Go to lavo.com/TWiRT. Take you right to the radio stuff right there. All right, we're talking watermarking strategy. And so, Paul, let's address what are stations typically doing not as well as they could be with regard to their watermark encoding?
Well, we beat to death using insert points. I think the worst place for an encoder would be at the front of your air chain after your console. So we've gone over that. Some other things, well, I had one client that I visited that was doing a lossy STL. Not exactly sure what brand they were using, but I think they were running AAC or MP3 256 or 320. And this is in a PPM market. And they were given a TVC15 to compare going linear versus continuing to run compressed. They went linear shortly thereafter. So that's an extreme example of something perhaps, but I've seen some clients believe that they can help with the 1 to 3 kilohertz spectra by just parametric EQing that range of the audio, which does a lot of damage. It's not something I would recommend. Just saying.
Okay. It does not damage listeners' ears. All right. All right.
So there's a couple things that I see people doing wrong.
So Chris, I would say, and see if you might say it a different way, Chris, from a theory point of view, you want to make sure that your watermark encoder has plenty of energy and density as frequently as possible in the 1 to 3 kilohertz range.
Well, yeah, based on theory.
Without making you sound bad. I mean, you don't want to boost that, crazy and, have the station sound all honky,
Right. Well,
let me step in.
Go ahead.
Sorry, you asked a question. I just suddenly came to the top of my head. I think there's some other things that folks can do. That's avoid multiple A to D, D to A conversions. I've seen that in a couple different instances, which can exacerbate the prevalence of the tones.
Okay, yeah, I would recommend for some folks. I mean, I know it's these days you don't do it anymore, but it wouldn't hurt to do a frequency sweep of your audio chain from start to finish and see exactly where it lies. We do that with our RF systems, our transmitters and AM sites. If you're going HD AM, what do? The first thing you do is you sweep the antenna system. Is it flat out, both sides of the sideband from the center frequency. Well, maybe you should sweep your audio path. Why not? Let's take a look, see. Maybe we'll see a peak or a dip or a lot of crazy erratic looking lines. I know it sounds crazy. When was the last time somebody did a sweep of the system? Probably never. 20 years, 30 years since we've gone digital with everything, you never do it. But there is something to be said. And as Paul pointed out with the lossless STL and people are still using stuff that probably may have issues, it doesn't take much to encroach upon the 1 to 3 kilohertz region, because that's smack in the middle of everything.
So imagine what happens with dry voice fed over a satellite channel.
Exactly. And also remember, harmonic energy, 2nd, 3rd, 4th, 5th, guess where it all lands when it goes in the wrong place? Oh, right. Mid-range, mid-band. What's that? 1 to 3 kilohertz. It doesn't take much energy to get bounced back in there. You may hear it as something warm and sounds cool because you got a fuzz buster on your guitar and go, hey, it's a great sound. Yeah, unfortunately, at the frequencies it's operating at, it's just destroyed your, watermarking.
Paul, you've talked about dry voice over satellite. And of course, over satellite, there's going to be psychoacoustic data reduction. In other words, MP3 or MP2 or AAC coding on those. And their whole idea is to take away everything but the fundamentals and the stronger harmonics. So if you're playing audio that comes from satellite or over any codec, you will have a spectrum that may be fairly free of places to hide. Although I did hear a little bit of a contrarian opinion on that. I think it was actually Cornelius Gould that said, these codecs aren't entirely bad because on the reconstruction end, they actually add some noise back in. And you end up getting some harmonics that may or may not have been in the original, but he says, I'm not sure they're all bad. So it'd be interesting to do some more experimenting, and I'm sure somebody has, do some more experimenting to find out what coded audio, what it's like to encode audio that's been coded, to encode with watermarking, audio that's been encoded and decoded, and then to find out how bad it is if you do bit rate reduction encoding after the watermarking. And Paul, you just said that one station discovered that it was bad, that they went to a linear STL and they found out that they were getting more frequent high confidence readings with their more green is better. Let's real quick ask the other question. For stations for whom some people say, hey, I can hear your watermarking, it sounds bad. My impression is this is what that TVC15 is designed to do. It closes the loop and says, hey, Mr. Voltair, you don't need to do any enhancement right here. Everything's fine. Let's turn you down and just turn you up during the awful national dry voice spot that doesn't encode very well. What are your feelings about that?
So true story is there are programmers that I've talked to that believe that the excessive tones that can come along with excessive watermark enhancement are the sound of ratings. They equate that to the sound of ratings. If they don't hear that artifact, they think that possibly there's something wrong with their chain. They're not getting the credit they deserve. So they're keying into that as a necessary feature in their mind. So they're processing to it, which is really not what you want to do. I've seen in some cases where if you over enhance, it can actually start to fall back in on itself. So you can do too much.
That's interesting.
And you can also aggravate your listeners to death as well, which I don't recommend either.
What I know and what I'd like to kind of end up with is I know that the watermarking system that we have in the U.S. Is possible for it to work without stressing the ears of listeners. Yes, there may be a few people who really know what to listen for, and they can hear it, even if it's unenhanced with a Voltair. And I should point out the Voltair simply it doesn't make the tones louder. It simply increases the opportunities for the encoder to put tones in. So it tells the encoder, hey, you know that decision you're going to make to not put the tone in right here? Yeah, go ahead and do it. It's okay. It's okay.
Well, it's no secret.
And you can adjust that.
The Voltair goes it goes up to 23, I think is the maximum setting. So look, 20 on a music station, if you're predominantly playing music, and not all program material, like Barry said, is created equal. So, on a station that's predominantly spoken word, you may just have to deal with excessive enhancement levels to overcome the weakness in your program material. Whereas a station playing country, today's top 40, modern music where the format and the processing style is pretty dense, you're not going to need as much enhancement. And you'll find that out with the TBC 1.5.
Do what Chris Tobin does, and that is put a teletype behind everything. that should help that encoder right out, shouldn't it, Chris?
That's a quilt. That's a continuous quilt. Just pick and choose.
That's a quilt lifter right there.
Moments.
You can, instead of teletype, you can call it the quilt lifter.
A quilt lifter. There you go.
Yeah. There you go. Hey, we got to go. I'm sure we can talk about this for a lot longer and bore some people to death. And I'd love to hear from our listeners. You can comment on our website, thisweekinradiotech.com. There's a button for feedback. I know because I get emails from time to time there. So you can do that. And I'd love to hear your thoughts, and we can talk about this topic again. I know there are plenty of people who don't like the system that we have, but I think there are plenty of people who don't like it because station bought a Voltair and leaves it turned up all the way all the time, and we don't recommend that either. So boy, lots of nuance here, but we want to keep the watermarking itself nuanced. Chris Tobin, thanks for being with us. I appreciate you participating today. Good to see you.
Oh, you're welcome. Thank you. And thank you, Paul, for joining us.
Thanks, Chris. Thanks, Kirk.
Yeah, Paul, thank you for joining us. And thanks a lot to Suncast, our producer, for producing our show, and to Andrew Zarian, the founder of the GFQ Network, where you'll find lots of other cool podcasts, including What the Tech. You need to check that one out. Hey, next week, we have Jorge Garza from McAllen, Texas, one of the very first users of audio over IP. Cool engineer. You're going to like Jorge. It's been a few years since I've seen him, so we'll see you then. All right, you guys take care. We'll see you next week on This Week in Radio Tech. Bye-bye.